Hello, boys and girls. Mr. G here, and today we're going to talk about how we can use what we know about arrays to help us solve multiplication problems. The first thing we need to make sure that we remind ourselves before we begin is that all multiplication and division problems answer three questions. How many groups? How many in each group? And how many in all? The part that talks about how many groups, we call that the grouping factor. When we talk about how many in each group, that's the each factor, and how many in all is the total. Okay, let's get started. So, what is an array? Let's figure that out by taking a look at a multiplication story problem and seeing how it applies. Steve has 4 bags of apples. Each bag has 6 apples in it. How many apples are there altogether? Okay, so first of all, I'm looking at this problem, and I know that 4 bags of apples, there's my grouping factor. That's my number of groups. How many apples do I have in each group? Well, looks like 6 apples in each bag. So there's my each factor. So in this problem, I have my 4 groups times 6 in each group. So I need an array that matches that problem. An array is a group of rows and columns that can represent our problem. So in this case, since I have 4 groups, I have 4 rows here. 1, 2, 3, 4. And I have 6 squares in each row. 1, 2, 3, 4, 5, 6. Therefore, this is a 4 by 6 array. So if I want to figure out how many I have altogether, I'm going to do 4 times 6. So let's skip count by 6s. 6, 12, 18, 24. Therefore, 4 times 6 is 24. And my answer must be 24 apples. Let's do an example together. So take out your packets and get ready to follow along with this one. Here in this problem, Alex eats 6 granola bars every day. How many granola bars will he eat in 3 days? Well, let's see, 6 granola bars a day. That sounds an awful lot like the each factor, because that's how many he eats each day. So that means how many granola bars will he eat in 3 days? Okay, each day is almost like a group of granola bars. So 3 days, my grouping factor is 3. That means that my problem here is 3 times 6, 3 groups of 6. My next step is going to be to draw an array that matches that situation. 3 groups, 6 in each group. So remember, I'm going to do my groups as rows. So I need a 3 row by 6 in each row array, a 3 by 6 array. This side is going to be 3. Side's going to be 6, so my array will be shaped like this. 3 rows, 6 in each row. I'm going to split this up into my 3 rows. And I'm going to make sure that I show that there are 6 boxes in each row. So this array matches up with that situation very nicely. How can I solve now? Well, let's see. 3 times 6. 6, 12, 18. My total is 18, so my answer is 18 granola bars. Let's do one more example together. Cassidy is super fancy. She wears 2 rings on each of her 10 fingers. How many rings does Cassidy have? Well, let's see. 2 rings on each. That sounds an awful lot like the each factor, which means 10 fingers. There's your grouping factor. Each finger is like a group of rings. So 10 groups times 2 in each group. It's a simple problem, but I still want to practice drawing an array that matches it. Take a moment and see if you can figure out how to draw this array. 10 groups, 2 in each. So this is going to be a 10 by 2 array. 10 rows with 2 in each row. So it's going to be tall and skinny. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows, 2 in each row. There's my 10 by 2 array. This is a great picture of this story problem, and 10 times 2, of course, is 20. So my answer is that Cassidy has 20 rings. I'd like you to do this next problem on your own. Pause this video, and when you're done, you can unpause it and move along. All right, let's try something else. Guess the multiplication sentence. I'm going to show you some arrays, and I want you to see if you can figure out the multiplication sentence that matches. So let's take this one as an example. I see that I have 1, 2, 3, 4, 5, 6 rows with 1, 2, 3, 4, 5 in each row. So this is a 6 by 5 array. That means that my problem must be 6 times 5. What is the total? Let's skip count by 5s. 5, 10, 15, 20, 25, 30. Let's see if you can do this next one on your own. Pause it. When you're finished, unpause and move along. Here's another one to try on your own. Again, pause it while you work. All right, now we're going to get really crazy. Here, I have a very oddly shaped grid. This is not an array because we have an uneven number of rows and columns. So how could we find the total in this figure? Well, what I'm going to do is I'm going to try and chop this into two smaller arrays. So if I draw a line, let's see, right along here, I could see that I have one array here and another array here. This array is, let's see, 1, 2, 3, 4, 5, 6 by 4. And then this array here is 2 by 4. See it? So let's see, if I find the size of this array first, 6 times 4 equals 24. Then I can find the size of this array. 2 times 4 equals 8. Now I just have to add them together. 6 times 4, that's the first array, plus 2 times 4 is going to give me the total. So 6 times 4 was 24, plus another 8, 32. See if you can do this next one on your own. Pause it while you work. Here's another example to try on your own. Good luck. All right, boys and girls, that was great work today. We figured out how we can use arrays to make sense of multiplication problems. Well done.